All right, we want to talk about scatter plots today. And so you see I have a scatter plot here on the screen, and that's what's located right here. And really what makes it a scatter plot are all these scattered points. And you can see they're all over the place, right? Scattered all over. And so we call it a scatter plot. Right? So what is a scatter plot? Is a graph of plotted points that can reveal a correlation between data. Now notice the word can. It can reveal a correlation. It may also reveal that there is no correlation between the data. So when you look at data that is clustered together along a line, then you see a correlation. And if you have data that is not clustered together along a line, then you don't have a correlation. All right, up in the right-hand corner is some data from the scatter graph. And if you use a graphing program, if you use Excel spreadsheet, then this data is available to you if you know where to find it in that spreadsheet. We'll talk about that data here in just a moment. So we've got a scatter plot. And it's always important to understand what's the independent variable, what's the dependent variable. So the x-axis would be study time in this graph, hours per week, and the y-axis would be the GPA, and that's on a 4.0 scale. So always important that we understand how everything relates. So let's talk about some of the parts here, and I may have to scroll up and down for you to actually see the scatter plot. But first off, let's talk about a trend line. A trend line. The trend line is that red line that goes through the scatter plot. A trend line can be drawn to show the relationships of the data. So if you're using a computer program, you can ask it to put the line on the graph. But if you're going to draw the line, then we call it a trend line, and you can draw it. How do you draw it? Well, first off, the line should be as close as possible, P-O-S-S, as P-O-S-S-I-P-L-E, all right, as possible, I-B-L-E. Oh, brother, I'm looking at that word thinking, what's wrong? I'm looking right there, right? As close as possible, I-B-L-E, to all of the points. And you can only get it, there's got to be there's a best place to put it to where it's closest to all the points. In addition to that, what will help you with that is there should be as many points above the line as below the line. So if you take a look at our trend line here, we've got 1, 2, 3, 4, 5, 6. This one's kind of splitting above, and what do we got? 1, 2, 3, 4, 5, 6 below. And we've got a couple that one's kind of splitting and that one's kind of splitting. Okay, so right, makes sense. We have about as many above as below the line for our trend line. Okay, now if you were to use a computer or Excel graphing program, then we're no longer going to call it a trend line. Right? We're now going to call it the line of best fit. The line of best fit. So graphing calculator, computer program, Excel can most accurately show that trend line, and now we'll call it the line of best fit. All right, the process to find the line of best fit is called a linear regression. R-E-G-R-E-S-S-I-O-N, a linear regression. And so a linear regression will allow you to find that line of best fit, and this is a computer program, and again it would be done within your graphing calculator, it would be done within Excel, etc. Now that linear regression will allow you to have the equation of the trend line of the line of best fit, and as you can see up above, it's exactly what we have right here. And notice, we're off to 4 decimal places there and there, but a program gave us that. And so now we have the line, the equation of that line. In addition to the equation of the line, you're also going to have the correlation coefficient, and that's R. The correlation coefficient R shows how closely the equation models the data. Now, a lot of programs give you, instead of R, they give you R squared. And if that's given, all you have to do is take, of course, the square root of R squared to get to R. All right, but R is called the correlation coefficient. And when I did Excel, it actually gave me R squared, and I converted it to R. Okay, so you have to be aware of that. Here's the thing about R. The closer R is to 1 or -1, then the stronger the correlation. The closer R is to 1 or -1, then the stronger the correlation. So let's go back up and look at our scatter plot here. And you can see we have an R of 0.9226. That's fairly close to 1. And you can see our dots are fairly close to the line. Now, if they were even closer, that number would be even higher. If they were more scattered or further away from the line, then that number would be lower. Now, we'll talk about this in a moment, but a positive correlation is for a positive slope. What is a positive slope? A positive slope is as you increase the input, the output also increases. So to increase the input, you always start left and go to right. All right, so we're going to start on the line. If I input a 5, I output a 2. Now let's move to the right. If I input a 15, I output like a 2.6. Let's move further to the right. If I input a 25, I output like a 3.4. Do you see how as I move from left to right, the line goes up from left to right? So the line is heading up, and if the line is heading up, then that is a positive slope, and therefore a positive correlation. All right. If the trend line or the line of best fit were heading this way, well, you can see as you increase the input, what's happening to the outputs? They're going down, and that would be a negative correlation. Okay. So we have a strong positive correlation as we approach +1. Now mathematically, obviously, as you approach -1, then you're getting toward a strong negative correlation. So approaching +1, strong positive correlation. Approaching -1, strong negative correlation. Is the graph of study time versus GPA a strong correlation? Yes, it is. So again, let's write it here. The R equaled 0.9226, and that would be a strong positive correlation. Strong positive correlation. All right, because of the 0.922, and it was positive, so the correlation is positive. Okay, got the idea? All right. So let's further think along these lines. So again, as the input increases, moving left to right, if the output increases, moves up, then there is a positive correlation. And again, R will be positive. And you can see in both of these situations, it's a positive correlation. Now, just a real quick line of best fit, I don't know, somewhere about in there. I'm just guessing, right? I didn't really bother to take the time to make sure I got as many points above as below, but something like that. And you can see the line goes up as you move from left to right. It's a strong positive correlation because we are clustered pretty close to that trend line. Now, in our second scenario here, it's a little bit harder to find the trend line, but I'm thinking, oh, sorry about that. Got to grab my pen instead of the pick tool. And I'm thinking about something about in there, maybe a little bit better, maybe something about in there. I don't know. But again, notice how the points are further away from the line. So this would be a weaker correlation, right? So we'll call it a weak positive correlation. Hopefully that makes sense. Well, you can have more than a strong correlation. You can also have, or a positive correlation, you can also have a negative correlation. So again, in this one, moving left to right, if the output decreases, then it's going to be a negative correlation. And of course, R will be negative. The correlation coefficient will be negative. And again, if I were to draw a trend line, I'm guessing somewhere, and again, quick guess, somewhere in there. Maybe I could have done a little bit better than that. I don't know, maybe somewhere about in there, right? Trend line. And on this one, I don't know, somewhere about in there. So obviously on the left, you have a strong negative correlation. and on the right you have a weak negative correlation, right? So strong on the left and weak on the right. Okay, are those the only possibilities? No. Oh, there could be no correlation, right? There could be no correlation of the data. So, you're actually running data. I don't know, you're taking a poll, you're trying to analyze data. You graph it and your points are all over the place. There's no way to tell where this trend line should go. Is it there? Is it there? I don't know. It could be either possibility, and therefore we just don't know. All right, so in this case, what should you expect the value of R to be approaching? Okay, so real quick, let's go back. Bottom of the page. We said the closer R is to 1 or -1, then the stronger the correlation. So where would you expect R to approach if there is no correlation? You got something? Are you thinking? Or you got to be a thinker, don't be a copier. If you think of it, you'll remember it for the rest of your life. If I tell it to you, you might forget it in the next 2 minutes. All right, and hopefully you're thinking 0. See, that scale is a -1 to 1 scale. So again, weak would be -1, 1 would be strong, and 0 would be right in the middle. So again, as you approach 0 this way, you're going from strong negative to weak negative to no correlation. And as you approach 0 from this way, you're going from strong positive to weak positive to no correlation. So as you approach 0, you're losing your correlation. Scatter plots. I think that's pretty cool. Okay, what else? What else? Well, we have a couple terms, and these terms are important that you know. All right. It's a little bit harder to test you over them besides the term itself, but the first one is interpolation. Interpolation. And what is that? It's predicting data points within the domain or input of the data. All right, so you can see here I have a scatter plot, very strong. What kind of correlation? Strong what? Strong negative correlation. This is a strong negative correlation. Now, notice R squared doesn't give us a positive or negative. So if I wanted to figure out R, I would take my calculator out. So let me grab my calculator here. And I'm going to punch in 0.9906. I'm going to hit the square root. 0.9906 square root button. And I've got a value of R of, and now just the square root itself is 0.9953. If I go to 4 decimal places. Now here's the question. Is that a positive 0.9953 or a negative 0.9953? And you have to know, because any number squared is always positive. That's why R squared is positive. So you have to know that this is a negative, right? So what would be the value of R? A negative 0.9953. All right, so just some thoughts there with what's given. Notice we have the equation of the line, and we have a negative slope. We'll talk more about slopes next chapter. Okay, so let's do a problem here with this. Use the equation of the line of best fit to interpolate the number of sales when the temperature is 48 degrees. Okay, so I could do this. I could try to read it off the graph, and I'm going to guess that 48 degrees is right about there. And therefore, I'm going to go up to my graph. I'm going to hit this point, and I'm going to come over, and I don't know, I'm going to guess 26 or 27. Okay, so I could guess. Now, this is definitely interpolation. Why? Because here's the beginning of the domain, and here's the end of the domain. And I'm definitely between those values, right? My lowest input is 30, and my highest input is 55. Am I not between those values, 48? I am. So I'm definitely doing interpolation. I'm within the data. Now, how do I get this exactly? All right, I'm going to use the equation. So come back up here. Let's use the equation. So y, the output, is going to be negative 0.8629 times x plus 67.505. And what are we inputting for x? The temperature, right? 48 degrees. Okay, so that's the input there. And once you input that data, use your calculator, punch it all out, you're going to get 26.0859. Oh, hey, I was pretty close when I said 26, right? It's 26.0859. Now, let's be careful. I always tell my students to make sure they ATQ, which means answer the question. So what does the question say? Interpolate the number of sales. Okay, well, y is 26.0859, but how many sales is that? Well, look at your scale, and it says in hundreds. So you better take this 26.0895, and you better multiply it times 100, right? And now you're going to get 2,608.59. You're going to have to round off, right? Because technically you're really going to get a point sale. So I would round that off to 2,609 sales. 2,609 sales. Makes sense? Interpolation. So we were able to use the equation of the line of best fit to give us a more accurate answer. We could have done it right off the graph, not as accurate. We can use the line of best fit, the equation of it, and we'll get nice and accurate. Makes sense? I hope it does. So interpolation, well, there's now the other side of that. So to interpolate is to do data within the domain. So what if you do data outside the domain? Sorry about that. My screen loves to jump on me when I try to switch pens at times. So what happens when you're predicting data outside? Well, it's not interpolation. You're not in, you're out, but we use extra. So extrapolation. So to extrapolate. To extrapolate is to predict data points outside the domain. Okay, so let's take a look at the domain. Let me grab my red here. The lowest point of the domain is 20. The highest point of the domain is 40. So if I try to predict something lower than 20 or higher than 40, I'm extrapolating. I'm using the current data to predict future data. And I have no current data within the domain that I'm talking about. Okay, so let's see if we can do a problem here. Use the equation of the line of best fit to extrapolate the income at age 62. So you see how we're definitely extrapolating? I mean, age 62. I mean, that's like out here, 45, I don't know, 50, 55, 60, right? You're somewhere out here. So we've got to go up here, and this line has to keep going, and we got to hit, and then we got to read the other scale. Do you follow? See how we're extrapolating? We're outside the given domain, and we're going to predict what's going to happen. By the way, these are just predictions, and the prediction is based upon everything continuing as it is. All right, so do you want to pause it and try to get the value? Why don't you pause it and see if you can come up with a value? Okay, are you back? So you took your equation, 940.43. You inserted the input of 62 minus 2467.4. And when you ran the numbers, you should have gotten a y value of $55,839.26. $55,839.26. Now this was a straight conversion because our income, notice, is in dollars. And let's see if that makes sense. So look, we're somewhere up here, right? Keep that scale going. Will we hit about 55? We would, all right? Which, by the way, if you stay at a company numbers of years, your income will go up, and you can end up earning a nice salary. All right, let's talk real quick about the correlation coefficient. So again, how would you get R? You would take the square root of 0.9384, right, to get R. Is this a strong positive, weak positive, strong negative, weak negative, or no correlation? What would you say? And I hope you say this is a strong positive. Notice the line is heading up as you go left to right, which means the outputs are continuing to increase. And such is the case. And by the way, you'd love to have your salary to continue to increase with time, right? And so that's what we have there. Okay, so a couple other questions here associated. Visually, what type of correlation? All right, we just answered that. We just said it was a strong positive. Now again, you should run the numbers on R, and let's go ahead and do that. So square root of point, right? We're looking at our R squared, and we're going to take the square root. 0.9384, square root button, and I get 0.9687. And this time R is positive, right? 0.9687. And hey, that's close to 1, all right? You might say, well, where's the cutoff, Mr. Scarfy? 0.9, 0.8? I don't know that there is specifically a cutoff. So as it gets close to 1, and we'll try not to give you some ambiguous questions to where you wouldn't know. Again, what's the value of R? We just calculated it. And R is, come on, pen. Boy, my board sometimes has been slow here. R is 0.9687. Okay? Got it? Good? All right. Awesome. Awesome. Let's do one more. Use the table to graph the points of the scatter plot and draw a trend line. Okay, so let's graph this. I've got everything set up for you already, right? I've got the months down there at the bottom, and I've got the temperature going on the y-axis. It's in degrees Fahrenheit. This is the average temperatures in Manassas, Virginia. And we've got January 33.5. And you're just guesstimating somewhere about in there, right? Hopefully you would agree. If you want to pause and do it yourself, go right ahead, right? And then turn it back on. We'll see how you did. All right, second month, February 36. A little bit higher, about in there. Third month, 44. I don't know, maybe about there. Fourth month, 54.5. Almost 55, somewhere in there. Fifth month, 64. We're going up and up. 64, about there. June, 73.8, almost 74, somewhere in there. And finally, July, 74.2. And I don't know. We only went up a tad, so right about there. Okay. So where are you going to put that line of best fit? Now, it's hard for me to do this on the screen, right? Because here, maybe I should use my line tool. All right, so I'm just going to start here. Let's see. Wrong one there. Let's see if I think, yeah, okay. So now hopefully I can manipulate it. Yeah, that's what I want. Okay, so yeah, beautiful. All right, let's see what I got. I have 1, 2, 3 above, and I only have 1 below. Let's move it a little bit this way. Now I have 1, 2, 3 below, 1, 2, 3 above, and it's going through the line. That looks pretty good. Now, do you notice here with trend line, right? Because we drew it. Hey, there's some room for variation, but roughly it's going to be in there. And we could interpolate data within the first and the 7th month, or extrapolate, but guess what? I wouldn't extrapolate too far because what's going to start happening as we get into fall, temperatures will start coming down. All right, but that's the idea, and that's the idea of drawing a trend line, and hope you did well with that. Scatter plots. In today's world, they get used a lot. In the business world, you can use a scatter plot to help explain your data. You can use the correlations, and those things are handy. And you as students should be able to understand what a scatter plot represents. You should be able to tell if it's a positive or negative correlation, strong or weak, By the way, what kind of correlation is this? A very strong positive, right? Those points are all real close to the same line there. So strong positive correlation. You should understand the correlation coefficient. The R, close to -1, strong negative, close to +1, strong positive, close to 0, no correlation. All right, scatter plots.